Hello and welcome to a discussion of Python, and in particular the Python syntax. By the end of this, if you make it through it, you'll have a pretty good understanding of how to write code in Python. This is maybe not the most engaging way to write it, but it is important, and especially if you're coming from another programming language, you'll be asking yourself these kind of questions. How do I declare variables, do conditional processing, and so on? We'll talk about each of these and go through them in detail. Feel free whenever you're watching this to stop and come back and rewatch because it may make more sense. I'll try to go fairly quickly so that those of you who are familiar with it can skim through it. So variables. A variable is something that holds a value, and the general syntax is that it's something is equal to something. There's no explicit data type. You can set it with functions, the results of functions. It can be essentially a function, can be a lot of stuff. The data type is based upon the last assignment that was made to it. So you can change the data type based upon when you set it. Speaking of data types, there's some very basic ones. You've got text, string. There's several ways you can create them. You can just put single or double quotes. Python doesn't care. You can also use the string function. Note that on this one example up here, this is kind of redundant because the result of str is a string. It's taking in a parameter that's a string. So you're saying take the string and turn it into a string, not necessarily the most brilliant coding you'll ever see. You've also got some functions inside of here, such as type, that's returning back also a string. And print is a way of showing things on the screen as you're familiar. Likely you've done so in the past, so it just outputs it to the console. These are all examples of doing assignments, and the name of the variable may help you. Sometimes you don't want to necessarily include the type, but try to make it where it makes sense. You've also got numbers. You can declare them in a similar way. There is an int function that returns back an integer from something passed into it. In this case, it's actually taking an integer and turning it into an integer. You also have floats. Similar sort of approach could be used with float. You can do explicit conversion by saying take this int and turn it into a float, and so on. You've also got complex values. So in this case, a j for some sort of complex non-real number. And then you also have complex function that takes an integer and turns it into a representation that is a complex type. Ranges are used whenever you want a series or a sequence from start to finish. You also have lists, which are an ordered arrangement of things. To create them explicitly, you can use a bracket, or you can use the list function. And then also, I always get those confused. Anyway, the square thing, right? And then you've also got tuples, which are a sequence of things. And a cool thing with Python is that a function can return a tuple, so it can be quite useful and interesting. You also have mapping types, say dictionary, so a way of having a name-value pair, and there's several ways you can get it. You can use the update function. You can also retrieve it with a bracket or update it with a bracket, lots of flexibility. You also have sets, which are like a Venn diagram set, so a mathematical set of things, an unordered collection of items. And then you can also have them where they're frozen so that they are immutable, so they don't change, right? So you can add things with the add function and so on. Booleans, as you would expect. Normally it's true or false, but you can also say convert it from a number. So anything other than 0 is true, 0 is going to be false. Capital T, capital F. Keep that in mind whenever you're setting true and false. Otherwise, it'll think that you're talking about a variable. And one of the things with Python you'll figure out quickly is you deal with runtime, not compile time, or errors. So you'll notice those problems when the code is evaluated the first time. Some of the editors have gotten better and help you, but you still want to be aware of that. Binary type, it's literally an array of bytes, right? So use that sometimes for things like images. Rarely assign them directly. Data types, the last assignment. So here you may have something that says X is a string, print it out, and it'll be of type string. Set it to a number, and it turns it into an int. So this is just making that point that it all depends upon the last time you assigned it. Whenever you write a program, typically you have flow control. That means that you control the direction that things, or the sequence that is evaluated using things like if, else if, and else. The elif is kind of the elif with an expression, so you can have a test inside of it like you have over here. So you can say if it's some condition, else if it's some other condition, well, elif, and then else is what happens if none of the other stuff is going to be evaluated to true. Ternary operations, similar in multiple languages. You may have seen one in C or C++ or C Sharp. It's some condition, a question mark, what happens when it's true and what happens when it's false. It's a short way of doing an if else statement. So you basically can use it to do something like this. So A, if A is less than B, else B, right? So it's a little bit of a odd syntax, but you kind of can get it. So anyway, moving on. Iterative processing. So the common things we do with programs is typically control the flow with if else, but also then iterate in some fashion. So typically either with a while loop or the equivalent of a for loop. So a while loop is while something is true, keeps doing the code inside of a block. If you hit a continue statement, it's a short circuit, take it back up to the while loop. So in this is an example of that continue. So while count is less than 3, and then if you hit it to where it's equal to 2, it goes back up and avoids this print statement. So you'll see 1 and 3. And then there's else, kind of an odd one. It happens after everything else has. So it's kind of almost like a while after the loop is finished, but inside of this context. So it's going to go through here, potentially doing even things like the continue, but then after all of the looping is done and this condition is no longer true, then you hit the else statement. That's kind of unique to Python. I don't know that I've seen that anywhere else. If you want to do a for loop, it's for I in range is one way of doing it, or for some variable name in some collection, right? So, and what we're doing here is actually creating a collection of 1 to 4, non-inclusive. So you get back 1 through 3 and print it out. So it's similar to doing the traditional for loop that you might have seen in other imperative languages like C or C++. Iterator is another way to do it. It's how it's actually kind of happening inside of the for loop. You don't usually use them. You could if you want to, but it's normally not something you have to do. There's also things that are kind of like looping in that they may apply, say, a function to all the elements in a collection. So you may say, I want to print this collection. And so to do that, you basically are doing a map operation. There's also the use of a lambda function, an unnamed function that's basically going to print out the square roots for you here of your squared values of the odd numbers, I guess it is, or times 2. It's not squared times or power, but it's times 2. So for the odd numbers, multiply them by 2. So anyway. The reason that you care about these is normally whenever you're doing something in a function like NumPy. From an AI perspective, and from a big data perspective, you typically don't do explicit iteration. You oftentimes use things like map functions to apply an operation to a collection of things. Whenever we deal with functions, it's a way of having an organization to your code. And a function is something that can be invoked repeatedly. The idea is to reduce the amount of code you have that does certain things. In this case, it's kind of stupid code, but the syntax is def, the name of the function, the parentheses, if there's any arguments, they go there. A colon to indicate scoping is starting, and then an indentation for the print statement, the methods within that function. This is a Python thing. There are other languages in the past that have done indentation as a means of scope control. It's a little ugly, perhaps, whenever you're first seeing it, but it is annoyingly concise. So if you compare this to like languages like C# where you're doing explicit scoping with your squigglies, your parentheses or your brackets, you'll see that this is always tighter because you don't have those opening and closing scoping statements. In invocation of a function, just use the function name and then supply any parameters. In this case, there are none. You can also have function with arguments, and also functions can return values. So in this case, we're taking in two arguments, we're adding them together and returning the result of it. So not a very useful function, but it demonstrates the simplicity of it. So add 3 and 4 together and return the result, which is what we get here, and then print the results that are being assigned to a variable named result. But the interesting thing, you may have been thinking math when you wrote this, but it'll also work with strings. Basically, it'll apply the plus operator to whatever those parameters are. You can explicitly name the parameters if you wanted to. In this case, I'm calling that same function, but in the ordering of the arguments, I'm putting the second argument first and explicitly assigning it, and the first argument second, and again, explicitly assigning it. Not necessarily all that beneficial for this particular case, but it is useful if you have default values inside of your function so that you set it to a particular value. So arg2 might be set to some constant inside of the declaration of the function. And you do that by just at the end of, after arg2, you say equals and then some constant value. That means that if it's not supplied, that's the one that's used. That's when named arguments become really important and useful. And there's also this arbitrary sort of keywords, right? So ** args is basically any number of arguments with any number of names. And so you can pass in what are essentially name value pairs at the end of it all. This is default values I was just mentioning. So if it's supplied, it overrides it. Otherwise, it uses this value. So if you call it and don't supply a value, then you'll get back the default value. Useful whenever you have a lot of arguments, not so much when there's one, although you may want a default behavior for your arguments as well. Recursion, to do that inside of Python is not that much different than any other language. You're basically going to call yourself. So a function will call itself explicitly or by calling some other function that eventually in turn causes it to be called again. And in this case, we're also using a little bit of a list sort of operation here. So we're doing the pop to treat this as a queue. So the function on the list is pop, gives you the top level item. And so this is showing what's happening as we recursively go through this, popping off values and then calling recursion, noting that this prints, then we go in here, go again. So anyway, play with it, you'll see what it's doing. But at the end of it all, this is a form of recursion that allows you to do operations in a sometimes elegant way, but you want to be careful because recursion can be confusing. So it's a nice thing to use, but you may not need it all that often. Libraries. The heart of any language like Python is going to be how many things it can bring in from the outside. In this case, we're going to pull in from the math library or module, the py function or constant. And we can evaluate it just by returning it in an empty cell, in this case in a Jupyter notebook. You can also do the using from import sort of syntax. So you can say from random import random int or randint, and that gives us a random integer in the range of 1 to 25 when we print out 3 of those in this example here. You can also alias modules. So you can say import math as m and then reference the m value. You see this a lot with things like pandas. You'll say import pandas as PD or something. Very commonly done. In this case, we're seeing a module, a class inside of this as well. Modules are a way that you can bundle together functions so that it becomes a bit more of a reusable construct. This is a simple class. So you do class, the name of the class, colon, similar to what you do with functions, except there's not really the concept of a parameter to a class, although there is a base class, which would be would look similar. These are the functions, so similar def, but this is a special function named underscore underscore init underscore underscore, and then with the parameters, one of which needs to be self. Self is how you reference an instance variable inside of your class. So if you have a function that wants to reference a value that's being set, in this case, self.name is associated to an instance of the class person. You use this syntax. And anytime you want to have a function that references that instance variable, meaning it's a instance function, not a class function, you need to supply the word self. So it's a little bit of an unusual syntax, but it's quite compelling whenever you use it. So here you can say import person, and then I can say Alan is an instance of person dot person. As I imported it this way, if I'd done it with an alias, it might have been shorter. And this is also in a subfolder sort of thing. So anyway, and I pass in a parameter for the name and the age. Notice you're not passing in self. That's handled internally. And then I'm also then taking an instance of it and saying introduction, and it prints it out. And yes, Alan hasn't been 29 for a very long time. So processing strings. Here's some example of how to use various string functions. Lots of them. Some string dot capitalize will capitalize the first letter in the string. Case fold will essentially do the inverse of the first letter. So Alan was here with capital A and W, and H turns into lowercase a, W, and H without impacting the other strings. You can do center within some space, and then with a terminating string, and then count how many times do things occur in code, turns it into a UU encoded sort of safe string. Probably not going to use that unless you're talking to something in the web, and then check to see if something ends with a string as well. And this is just kind of scratching the surface of strings. All kinds of functionality. Expand tabs, turn tabs into spaces. The find looks for the first instance of something within it, so it's finding it here at AES was. Format is for an F string. Sort of syntax so that you can format the strings using string.format. Also, for simplicity, if you have a $sign in front or an F, lowercase f in front of a string, you can then do string formatting inside of it. But lots and lots of things you can do with strings, and this is just touching the surface, and it goes on and on. So lots of string functionality. Whenever you're dealing with programs, there's always errors and exceptions. So the way that you can handle them inside of Python is similar to other languages. You have two kind of flavors of errors, if you will. One is syntactical errors, meaning you didn't follow the rules of the language. So there's, this isn't valid Python. Another is a runtime exception. So it was syntactically correct, but it results in an invalid state and condition. So whenever you're dealing with exceptions, syntax errors you fix, right? You correct your syntactical mistake. You follow the rules of the language. Runtime errors that you have that are exceptions, you can either not deal with, that's one approach, maybe not the best one, or you can use a try and an except. So try, some series of things, and then except whenever something happens, a particular type of exception, in this case, a value error, and then you do something, right? And then you can catch explicit ones, so OS error and so on, and you're giving that OS error a name, so as error, so you can then refer to it and actually print it out. You can also raise an exception. It's similar to a throw statement. So raise a particular error or exception with some parameters, and that causes an exception to be raised higher up in the call stack and hopefully caught. And it's a way of handling exceptions in a true way. The thing you want to think about with exceptions is it's not flow control, and don't use it for that because it is going to be pretty inefficient if you do so. So don't be tempted to use an exception as a way to replace something you should normally be doing with like an if else or something. And then there's a finally statement, which is used in conjunction with try except. It can be just with a try. It's something that will be evaluated at the end. You oftentimes use this if you need to clean up after yourself inside of some sort of a library talking with a low-level resource. More complex examples where we're basically stitching together a divide function. So it's simply taking a result and two parameters and doing division on them. And then it returns, if it's a zero division, it returns, if there's not, it returns the result. And then the finally, so you do have this else clause in here as well, which is kind of an interesting construct inside of Python. Don't know that you normally see this. Normally this print would probably be included after the result statement inside of that try block if you wanted it to always occur after successful completion. Although it's a little weird, right? Because even if an exception occurs, this else will potentially occur, right? So assuming that you're anyway. Odd syntax in Python at times. You don't typically do it. Scoping, this is a little different, and scope is an overloaded word, right? You have scope of a variable and you have scoping of functions. So inside of this scoping of functions, indentation is how we're doing it. But I also, inside of this case, I'm defining a variable x. And the thing about it is, it's only going to exist within that function. So if I say some function x equals something, and then after I've exited out of that function, having invoked it and printed out the result, if I try to print the value of x, it doesn't exist because it was inside of that scope. Same sort of error over on the other side. To work around that, there's 2 or 3 ways you could do it. You could use the word global, or you could just declare the variable globally. So in this case, we initialize it to 300 and then print it out. And so it's there. Inside of here, it's 300. We set it to 200. And in this case, this is where it's kind of weird. You've got 2 variables with the same name, but this x is going to be local to this function. You have to use the global keyword if you want to really have it be the same thing. So if I say global x, or I could have global x equals 300, you could combine those 2 lines together. Then you're creating a variable that exists outside of it. You don't have this scoping issue that you had because this is telling my function here that it wants to use this variable, not introduce a new one. So interesting sort of nuances. You want to be careful when you're working with it to make sure that you're understanding kind of what's going on. Classes, I talked a little bit about earlier. Class is something that is a way of doing reusable code, right? So the idea being to pull together reusable functions and variables that go together and combine them together. So here's a class that has just data. That's an instance variable that's going to exist. There's no functions because we don't have any defs. Inside of here, we have a def function that's being defined. So we're defing a y function with a parameter of self, meaning that it's an instance function. So whenever we invoke it, it will use this variable here as what it's printing out. You also could have changed that value inside of the function either by passing an argument or some other thing. And this is that init that I was telling you. That's essentially a constructor, what we would call it in most other languages. So with that, thank you. A lot to talk about. I hope you enjoyed this. If you did, let me know. Like and subscribe as always. If there's something I didn't get quite right or I misspoke because I was going pretty fast, let me know that too. Always want to make things better. I will talk with you later and stay safe.